So in this video, we're going to solve the given differential equation by using an appropriate substitution. So our differential equation is dy over dx is equal to sine of x plus y, which is of the form dy over dx is equal to any function f of ax plus by plus c. So since our function, which is in terms of x plus y, is in this form f of x plus y, which is the same form as this one, only a has value which is 1, b has value which is 1, the coefficient of y, and c has a value of 0. So see, this function here, sine of x plus y, is a function in terms of x plus y, which basically is in this form with these values of coefficient. So we can now decide a suitable substitution or the appropriate substitution, which is we can set any variable v equal to x plus y. So we'll change this as v. So the next step we're going to do is derive or take the derivative of v in terms of x. So we'll go dv over dx is equal to dx over dx plus dy over dx. So dx over dx is just 1, so we'll change that one. So we now have dv over dx is equal to 1 plus dy over dx. But we know that dy over dx is sine of x plus y. So we'll use this one here and plug this in here. dv over dx is equal to 1 plus sine of x plus y. But the thing is, I don't want to use x plus y because we've used a substitution variable which is v, right? So I want to change this x plus y as v. 1 plus sine of v, so that our differential equation now is in terms of v and x and not x and y, okay? So the next thing we're going to do is separate the variables. So I've discussed this a lot in my previous videos where the separation of variable is considered. So let's go multiply both sides of the equation by dx all over 1 plus sine of v. So multiply this one dv over dx times dx over 1 plus sine v, cancel dx. So we have dv over 1 plus sine of v is equal to, next is to multiply this to this, 1 plus sine v times dx over 1 plus sine v. We cancel out these two, so we'd be left with dx. So now it's easier to integrate both sides of the equation because we've separated the variables, right? But how do you integrate this one? Integral dv over 1 plus sine v. So we take a look back at the difference of two squares, which is a squared minus b squared. And the formula for that, when you factor this difference of two squares, is a minus b times a plus b. So as you can notice, we have 1 plus sine v here in our denominator, so we can actually make this a plus b or a plus b. We make this 1 plus sine v or a plus b, so we can have 1 plus sine of v. And if our a is 1 and our b is sine v, then we should expect our a minus b to be 1 minus sine of v. So that's definitely a squared, 1 squared. 1 squared is just 1. B squared is, our b is sine of v, so that's 1 minus sine squared v. Okay, so after that one, divide both sides of the equation by 1 minus sine v. The reason is I want my 1 plus sine v to be left alone. and isolate it in the right hand side of the equation. So that we'll get 1 minus sine squared v all over 1 minus sine v is equal to 1 plus sine v. But this one here, the integrand is 1 over, because this is basically 1 over 1 plus sine v dv. So I want to make this form. So I can make that form when I take the reciprocal of this here. So the reciprocal of this one is 1 over 1 plus sine of v is equal to, if you take the reciprocal of this one, you should also take the reciprocal of this one. Okay, 1 minus sine of v. Bring this to the numerator and bring this to the denominator. That's just it. 1 minus sine squared v. So now we have our integrand here. Let's go plug this value here in our integrand. So let's go delete these. Okay. So remember, our integral was 1 over 1 plus sine v dv is equal to integral of dx. Okay. So let's go plug this in here. This one here. 1 minus sine of v over 1 minus sine squared v dv is equal to the integral of dx. Now remember our trigonometric identity, which is sine squared v plus cosine squared v is equal to 1. This is the most basic Pythagorean identity. So we can subtract minus sine squared v to both sides of the equation. So that we're left with cosine squared v is equal to 1 minus sine squared v. Okay, so let's go plug this in here. Let's change this in terms of cosine. The reason why I want this to be changed in terms of cosine, because I want this to integrand to have a pattern, have this like common, or we have this, we can make a pattern out of these ones. Once you divide 1 over cosine squared, once you separate the denominator, 1 over cosine squared v minus sine v over cosine squared v dv. Now you'll see some patterns is equal to integral of dx, because we already know that 1 over cosine squared v is just 1 over cosine squared v is just the reciprocal of or equal to secant of v. So that means secant is the reciprocal of cosine and cosine is the reciprocal of secant. So I wanted to make this in terms of secant, because in that way I know I have an easy answer for that integral. So 1 over cosine squared v is secant squared v minus, we still need to look for some integrand, some patterns where we can integrate these easily. So we want this to be like cosine of v here, cosine of v here. So we just separated the two cosines because I want to express sine over cosine v as tangent of v and 1 over cosine v as secant of v. So this would now be sine over v over cosine of v is tangent of v. 1 over cosine v is secant of v. Now, it would be easier for us to integrate this because these are already formulas. So integral of secant v dv minus integral of secant v tan v dv is equal to integral of dx. So we know these already. This is tangent of v minus this one here is secant of v is equal to integral of dx is x plus some constant. So we would like to substitute or plug the value of v in terms of x plus y, which is now tan v is tan x plus y minus secant of x plus y is equal to x plus some constant c. So this is our final answer, which is the same as this one. So that means our answer is correct because we have a check mark, and thank you for watching my video.